Okay, make sure you do the attendance quiz. Oh, there it is down there at the bottom. Oh, I've covered up the password. Hold on. There's the password. Should be the password anyway. And mostly what we'll do today, I think, is looking over homework one, which is due Thursday, and making sure we all kind of know how to solve that kind of stuff. A lot of that's coding. Actually, it's all coding and a little bit of cut and paste data type stuff. But I got a decent number of questions about that, and so I think it'll be good to go over that. Today, we probably won't actually do in-class soldering. I'll go through like a PowerPoint about soldering, but on Thursday, everybody at that point should have all their refund checks in. Everything should be to where you should be able to get the actual kit. And then we won't solder in class. I'll solder in class just to show you, what it looks like in person. And then the room next door has 3 or 4 soldering irons in it that you can use, or you can solder wherever you want to. There's some downstairs, in some of the prototyping labs. I think in the 3D printing lab, there's some soldering irons, I think. Anyway, that should get us up to speed. A lot of people have been asking how much is the class about coding, and it's not about coding, but there is a lot of coding in the process of collecting all these measurements. On the exams, how this works is the exams are multiple choice, so you don't have to ever write code on the exams. So the way it would show up would be, I could envision some kind of maybe a block of code and multiple choice questions about that, as far as what is the output or something like that, or maybe a thing you want to do and then multiple choice pieces of code that potentially do that thing and you pick the right one. But you're not going to write code from scratch on the exam, and the exams aren't going to be much about coding anyway. Obviously, since we spend a good amount of time writing some kind of code, then we'll ask you something about it, but that's not going to be the point. And don't ever feel necessarily like it's wrong to go Google how do you do whatever, and then somebody on the internet has their example and it's different from what we did in class. It's okay if you write your code differently from the way we write it in class, just because I might not write the same piece of code every time to do the same exact thing, because I think of a different way to do it one time versus another. And so it's okay if your code solutions are different from the ones we do in class. What we'll do, like in homework one. So let's just look at homework one. I think it's back on class 3. Why is it? I don't know what it's doing here. It's kind of weird. And I've been posting what we talk about in class. It's kind of probably difficult to find things in there because I don't timestamp anything, but I don't know. At least you have it. You can look at it. All right, so here's what we were asked to do for homework one. 3 different things. One of them, oh wow, why is it going so slow this morning? Did I hit record? I did hit record. All right. All right. So homework one is kind of leading you into the idea that, hey, you have a piece of code that does something very similar to this. You have like the custom function code that we started out with on maybe class 1. Does temperature conversions as part of what's built in there. And this one is asking you to do pressure conversions. So the idea here is I would take your existing custom functions, copy the temperature conversion part of that. I think it's even called tempcon instead of presscon, like this is asked, and then paste it further in that same custom functions, or wherever. You can create a new file if you want to. But then change it all from temperature to converting pressure. And so this one should be the most straightforward, as far as you have an example that's almost exactly this thing, and then just sub out the pressure conversions for the temperature conversion. Actually, do that the other way around. But this little block of code right here that's shown is basically the test. So you copy this. Now, you can't cut and paste from this document exactly, so you have to type it in, I assume. But type in this piece of code and run it. And assuming you've got everything set up correctly, then you should get this piece of code referencing your pressure conversion function that you wrote, and basically running through all of these units and converting between them. So it should have a whole list of output of pascals being converted to kilopascals, megapascals, atmosphere, blah, blah, blah. And then kilopascals being converted to everything. So it should work that way. It does have a couple of little things that you have to be sure you do. So problem 1 needs to be the name of what you wrote. So what your script needs to actually match up, otherwise it won't import it. Hopefully you noticed that, but maybe you didn't and you don't know. Where's problem 1? Problem 1 is the thing that you will write that this piece of code imports as CF, custom functions, I guess, is what we used for CF last time. And then it will run. So this one should be a lot of taking the existing code you have and modifying it to go from pressures instead of temperatures. This one is very similar to the football code, where we went and grabbed a block of data and processed it for figuring out the points per game and the points per game margin and that kind of thing for each team, and then figuring out who is the maximum and minimum. This one, the difference is doing all that same stuff except plotting the results. And other than that, it should be very similar. The difficulties here usually seem to be coming in creating the CSV file to begin with. So seems like the ones that I've seen that people had issues with, the CSV file was treating, maybe you copy an extra line at the top or bottom, and it doesn't corrupt your data, but it puts data points in your list that it doesn't know, your code doesn't know what to do with. Maybe they're empty or blank or something like that. It doesn't know what to do with that, or string to floating point type things get creep in. So it would work okay if as strings for most of the code, except a string doesn't have like a numerical value. So when it goes to plot it, it's kind of all over the place. Like the y-axis wouldn't necessarily be ordered. It would just be whatever order they showed up in the list. And so that could be a problem. So there's little details in there that are hard to track down on what's going wrong. And a lot of them go back to, did you get the CSV file created correctly? But this one, you would basically take what we had for that NCAA football and use that as your base for getting the CSV file in. You have to go to the Weather Underground site and download the data to begin with, and then processing it just to plot it. And we do have a plot number 6 or 7. I don't remember which one. Shows how to plot multiple things on the same chart here, and so that's pretty straightforward. And then there's some little things that you might not notice, like by default, this is a year's worth of data, so you have 365 numbers at the bottom, and by default, it's going to label every one of them, and they're all going to be crowded together. So I don't think we went through any examples where there's a way for you to modify. This one's only showing every 50 data points, whereas by default, it's going to show every single one from 0 to 365, and they're just going to be too crowded together. So you might have to search. The thing to search for is X ticks and Y ticks, I guess. So X axis tick marks, and there's formatting options for, do you want to show every 10th one or 50th one, or what do you want to show? Same thing for Y, and those are in the plot command. So, and then you can put parameters on how you want those things to show up. So that, and you can do the same thing for X and Y, because Y will have a similar issue where it goes from like 0 to 100 and they're kind of crowded. So that one again, other than the CSV file is not too different from what we did with the NCAA football data. You can take most of that piece of code and translate it over to make sense with this weather data. This last one is a little different though, because it's pulling from, from 2005 to 2018. Each one of those is a separate Excel file. If you go to the, and I did put on Moodle, I did put more direct links, like right here, to go directly to the place that these homework problems are referencing. So there's the Bureau of Labor Statistics, and here are all the Excel files from 2018. I don't know how far back it goes. Well, it's 1997, I guess. And so each one has a national XLS, so it's going to be an Excel type file. And there's 2005. So you have to go get each one of those. As far as I know, this site, the BLS.gov, doesn't have like one giant Excel file with all this data already in it. So I think you have to kind of create your own. You could do that by making a bunch of individual Excel files and running through those, or maybe a bunch of sheets in this combined Excel file. That might work. I guess you could like literally go into each one of these and cut out the data that you want and paste it into your own Excel file. You could do that. It would probably, I don't know, it depends. So your comfort level with coding kind of determines how much brute force you do versus how much you have Python or whatever you're coding in do. So if you don't have a clue, then you could go in, get one of these Excel files, chop out the data. Well, let's look at one and show you what it looks like. Let's see. Here's what one would look like. And there's a lot of data in these things. All right. So we're looking for particular, we don't want all of these careers. We're looking for particular ones about, there's one, biomed. And so most of them have this broad and detailed version. So there's two for biomed. Now, a lot of the engineering ones are actually the same. Notice all the numbers are the same over here. Some of them, I think industrial. So industrial has one broad group where it combines industrial engineers and includes health and safety. And then later on, it breaks out just industrial engineers. So sometimes I think you can always, from this type of list, you can always get the detailed one. And it'll just be the group that you're looking for. So you're looking for industrial and mechanical over here, and biomed, civil, chemical, and I think that might be all the ones you're looking for. So you could go and like grab these rows and get the data you want. If you look at the headings, the things that you want are, you want the annual, so A in these mean annual, the 10th percentile, the 90th percentile, and the median. So N, P, and R. So you could go and like cobble together your own data sets from each one of these. That would take a while to do because there's 2005 to 2018 that it wants you to do. So it could take a while to do that, but you could manage it that way. But what I want to do is I put a link on today's class, I think. So let's see. Yeah, I think it's this one. So this is going to walk us through using Python, external. In this case, it's a single Excel sheet, but we will show how you could use different sheets in the same one for election data. And using Python, Pandas, it'll use Pandas. That's a database plugin library for Python. And parsing through some data similar to this kind of data with the labor statistics. So what the general thing here is that it's going to go in, and there's a database here. Let's see if I can open that in a new one. So a bunch of data here. and it's just a website that goes back to 1976, and it goes through 2016 is the last update it's had that I saw. And we can go to this link here and find the actual data file. So here's the data set, and we can download this. Now this one is .tab, not .csv. So CSV was comma separated values. When it says .tab, it's a similar thing, except they don't use commas to separate everything. They use tabs. So it's a tab delimited data file. So a little bit different, but same idea where you're using something, some marker to separate all the little pieces of data. So you could go in here and download that, and download it as a tab delimited file. I've already done that, so it'll probably, I don't know what it'll do. We'll see. All right, so I open the folder to see where it put it. I put it in downloads. All right, so I think I've already moved it from there. I think I currently have that in, I don't think we need that anymore. Nope. I think I have it in my 382 in class. I think it's in here. There it is. Now I actually have two. There's the tab delimited, and then I have a one that doesn't say tab on it. So what happens here? Let's go back to our, not there. Go back to here. I think we can close these. All right. So now we have this Excel sheet that has all this data in it. And what we're going to do is we're going to go through and parse it. We're going to input two, let's see if I can, yeah, two pieces of data. We're not going to actually do, we're going to hard code these into the code. So if you wanted to change them, you'd have to hard code the actual Python code to change them versus there being queries that it asks you to do. We could do that later on, but right now we're just going to hard code it in. So this is your birth year. Well, not necessarily your birth year, but a birth year and the state you were born in, and it's going to go match those two, find the nearest election, because elections were only every 4 years. So find the nearest election year to your birthday and the state you were in, and figure out who won that state, and it'll plot out some data. Yeah. To open this, we're going to open it in Excel. Yeah, you might have to go to Excel and open it from there versus open the file and have it know where to go, because chances are you've never associated a .tab with any particular thing. So open Excel first and then open it. And that should work, I think. Or drag and drop it onto Excel should probably work too. All right, so then that's this point here, this .tab file. Most of your setups aren't going to know what to do with that. So we're going to switch it over to an Excel file, and we'll do that by opening it in Excel. So this is our other data. We don't need that. Let's close that one. And then let's open. Oh, there it is right there. So the actually, this is not the one I want. This is the one that's already converted. Let's open the one that's .tab. So I've already done. So there it is, .tab. Let's open that one. So, I moved it though. So I actually have to go navigate to it. All right, file, open. I put it on this PC. It's not in documents. It's on the desktop in 382 in class, but it's only showing me the Excel files. I wanted to show all of them. Can I force it to do what I want it to do? All right. Maybe if we go here, and so I just grab the .tab and I want to drop it onto Excel. Maybe it'll behave better. Oh, it's not acting like it.
Go to open and then all file types.
There, it eventually did open up this way, or like he's saying, you can go to open. Or I don't see where all file types is though. Browse. Oh, down here. Yeah, I went to this PC. Okay. You have to use the actual file manager to go to it, and then all files. And there it is. All right. So you can drop it onto Excel on a blank notebook, or go to Browse instead of this file manager. It doesn't work for what we want. All right, now where's it go? I don't know where it went. Let's open it again. There we go. All right, so and it reads it. It knows, or it assumed it knew that tab delimited meant to splice it up or parse it out by tabs, and so it looks reasonable. But it's it's all this data, so all this stuff. So to convert it to an Excel file, all you do is you get it in Excel and then you save it. So we'll do File, Save As, and then we're going to save it. The two main things, you've got XLSX, and then somewhere in here, yeah, there's an XLS. So that's those two are the Excel file types that are probably what you want. XLS is just the older Excel, so it ended in 2003, and the one with the X on the end, on both ends, XLSX, is the more recent version of this same workbook thing. So we're just going to save it as that. And we're going to erase this .tab off of it because I don't want that to be part of the name. So 1976, and then mine probably won't work because I already have one there. Yeah, I guess I could replace it. Yours won't say to replace it because you don't have one there. And that's it. You've now converted it to an Excel file. It looks exactly the same, except now it has an Excel extension, and now you could actually click on it to open it versus doing Excel open and all that kind of stuff. So that converted it to Excel file. Last time, we saved as a CSV, and we used our own little parser to go in and chop it up to figure out where the commas were and sort it into these lists and everything. This time, we're going to let somebody else do the work for us, if I can find the right thing. This little block is just talking about basically saving it as Excel file. Well, actually, this block talks about saving it. And it does go and talk about a little bit about the XLSX and S, but this Pandas. So the Pandas library, you added one library, PyPlot or something, Matplotlib. You added one of the libraries earlier on. Pandas you probably haven't added. Well, you might have, because you might have already known that it's a useful tool for running through all these database files that we've been working with. So you might have already added this. If you haven't, then here's what you can do. You can go to get your Thonny running. There are multiple ways to add libraries that actually are mentioned in there. Let's get rid of that one and start a new one. If you haven't added it, then and you don't know a different way too, if you go to Tools and Manage Packages, then just type Pandas and find that one. Then there should just be one, and mine says uninstall because I've already installed it, but yours should say down here install. Click on install, it'll download it. You do have to be connected to the internet or it won't even find it. And then it will give you functionality that you didn't have before as far as database management. Yep. It is in, oh yeah, if I ever do something you're like, just ask. Tools, so I'm in Thonny, Tools, Manage Packages right there. I don't know if there's another way, but that's the way I got to it. And then you just type what you're looking for. And it'll should find, yeah, I don't know what Jedi does. Oh, it's an auto completion tool. Oh, that might be kind of handy. So you start typing a command and it finishes it all for you like a Jedi would. You can add it in and see what happens, but I don't know. I've never used it. There's another one that we want to get also, XLRD right here. You might as well go ahead and install that because it's a thing that Pandas uses. And so it'd be good to have both of those. So get Pandas. This pip install Pandas, that is a command line approach if you're using command lines. I assume most everybody in here is pretty new to Python, and you're doing exactly what it says on the sheet here. So if pip means nothing to you, that is okay. It can stay that way for now. Actually, it can stay that way the whole quarter. Just go get pandas and XLRD into Thonny. You get XLRD the same way. You look XLRD, find it. Mine's already installed, and so you install it. Tools manage packages inside Thonny. Tools manage packages. Yeah, they're both on there. And you need both of those. Let's get my notepad back up. You can't download Jedi. All right, so you want pandas and XLRD. Oh, you might also, I didn't specifically say this, but you might want to navigate to this. So this was on Moodle on today's date, the one that says Excel data and Python. Click on that and it'll take you straight to this page where I'm looking at. You might want to do that because this one you can cut and paste Python code from versus typing it all. I'll type it for a while, but down here at the bottom, it gets a little bit dense. I'll probably cut and paste that stuff. And at the very bottom, I think there's a link to the whole code. So you could just copy the whole thing. Although there's some value in typing it just to get that one extra way to possibly remember it. All right, so at some point you'll get pandas and XLRD installed in your Python directories. So the very first thing we need to do is we need to import pandas. We're going to import it as PD, just so we don't have to type pandas every time. We only have to type PD when we want to do something with it. So where's Thonny? That'll be the first. We can close that. You don't have to match up with the code that we write. You would, but basically anywhere we write PD, you would have to write whatever you wrote. I'm actually not 100% sure what the rules are on the name here. If it has to be can it be a single character? I don't actually know. I guess we can find out. P. Oh, you have to save everything. So this will be in class pandas. So yeah, maybe it can even be a single character. I actually have never investigated the rules on that particular naming. So now we have this pandas library available in our Python code. And it might, depending on how, these aren't huge libraries, so depending on how your connection is working, it shouldn't take more than a minute to download and install them. But it's possible that it does just because internet. These two depend on what you're actually using to display your output. So if you're using exactly what I'm using, then how about we copy these and put them in, but leave them uncommented so we can see what they do later on. All these do, there's PD, so that's pandas, and there are two options, one for the display column and display width, number of columns to display and how wide the display will take up on the screen. And so in here, all of our output is going to pop into this shell down at the bottom of the screen. And by default, which we currently have because these are commented out, so they're not active right now. So the default will be that it's not going to show us all of our columns because it's going to have to squeeze it into what we have available. So I'm going to hold on to these options. And once we have something to show, then we'll see what these actually do. Yep. All right. Let's see. So those I'll leave comment. All right. So here, what we're doing is we're going in and inputting. This is our way to give our Python code some input about us, I guess. So our birth year and our birth state. So you can put any, well, not any. because our data only goes back to 1976. So I put mine in, and it's before that, and it actually doesn't work. So I have to put in some other number. Let's do 1983. Let's do that one. And then what's the other thing we need? First state. Oh. So you do have to make sure you spell these. And let's see, I think it wants capital. Some of these, the data is lowercase. This is going to be a lookup. So if you spell it differently than it is in the database, it will not find it. So you have to spell it. And there's no, I don't think any of the data is abbreviated. Do we still have it open? Actually, it does. It has both. So depending on which column you're going to look under, we're going to look under this state column, but if you were looking under the state with the post office abbreviation, then you could use that. But the state column has it completely spelled out everywhere. Okay. All right, so now we have given it information about what year we're looking at and what state we're looking at. So still no output. It doesn't even know the database yet. All we have is a thing to work with database and 2 pieces of information that it knows but doesn't know what to do with. All right, oops, let's go to here. All right, so here, this DF data frame, that is going to be where we store all of this data from the Excel file. Now, this one is a little bit different. We've done this before. We called it, what do we call it? F, I think. F equals open data, the file. This one's a little bit different because we're going to open a particular sheet in here. Now, this file only has one sheet. It only has the one down here, so we don't actually need to tell it which sheet to open. But that may be useful for homework 3, where maybe one way you create this database that you're grabbing from the Bureau of Labor Statistics is to put each year in its own sheet down here. So you have a bunch of sheets across the bottom of the screen. This, you could use that sheet name to go to a specific year and grab that data, and then go to another year and grab that data. You could do it that way. So this one, the sheet name doesn't do anything really because we only have one sheet. But now this would not work for me, because if I look at my folder, I named 1976 to -2016-president.xls, and this is looking for 0.8.1976. So you have to have the file name exactly the same as what you filed it. The sheet name, this has to be exactly the same as what's on the sheet down here, which that does match up. But the 0 or 0.8 point little number in front of that file wouldn't work for me, because that's not what I called my database or my Excel sheet. So now I've got the data into this variable, or this data frame, whatever we want to call it. DF contains all of the data from this Excel sheet, just this one sheet, which is all of the data. So now we actually have stuff. It still has no output. If I run this, it shouldn't give me any errors, but oh well, it actually did give me errors. All right. Permissions, and oh, you know why? Because I have it open. So Excel is also looking at this file, so I need to tell Excel to let go of it so that Thani can look at it. All right, so no output, but I didn't ask it to do anything, but at least I have no errors. It is not a bad idea to write a few lines of code and then run it and see if all of those lines are correct, and then add another line and run that, and that will make error tracking a lot easier versus having all of your code and you might have 6 or 7 errors in the block of code. So just do a few lines, run it, see if anything bad is happening, fix that, and then keep going. So we're good right now. It just doesn't do anything that we can see. All right. This little block just talks about what this is doing, basically what I just said. All right, so here This command is unnecessary, but well, actually that command doesn't do anything. Why don't we, well, if we print it, then it should print out everything. Actually, this DF, if we did print DF, then it would print out everything, I guess. But this head will only print out the first 5 rows, including the headers. So it starts at the top of the database and prints the first 5 rows. So let's try that and see what happens. All right. All right, there it is. So it took a little while. I had to read through everything. Notice this one we did not eliminate the headers on. The one that we did last time, we did pop 0 to pop off the top row, and I think we actually did that twice to pop off the top 2 rows. This one we didn't do that to. Pandas is actually able to read these headers and use them as search terms. For lack of a better explanation, that's what it's going to do. So we don't want to remove the headers. We actually want to go in and look for the column that has year in it and then find a particular year in that column. Now here, these dots, these ellipses, those are, well, not in there. Up here, these options here are controlling how much of this data we can see. So if I turn off this, now I've got, it'll show up to 999 columns. So I've got, it says I have 14 columns, but it's only showing me 1, 2, 3, 4, 5, 6. It's only showing me 7 columns, even though it says I have 14. So if I tell it to display 999, then I run it, and I get more, but it's, it's slicing them across here. And that doesn't actually change. Like if I change my font to something smaller, font, let's go down to, make it hard for y'all to see, but let's go down to 10. It still chops it off. So this one, the display width is basically, it defaults to, I don't know if this is 40 columns or whatever it is, probably 40 columns that it displays is defaulting to. But I can tell it to say, no, I want you to display width of 1,000 columns, which is ridiculous, but we can tell it that. And then when I run it, I get everything. Now, it's still not fitting on there, and that's more my screen. I have to make my font even smaller for it to actually fit on there. Let's go down to 6. Oh, 6 works. What about 8? 8 looks like it works too. So, oh, but it didn't. There it is down there, without having to slice across some rows. But in tools, options, size, I'm going to go back to my larger size so we can actually see what's going on. It's the editor and the shell. I don't know why it disappeared on me though. Oh, can't I? Like change one way and one the other way? I don't know that. I don't see a way to change the font. There probably is. I don't know it. But there probably is a way to change the shell's font size without changing the editor's font size. You did? Oh, I didn't even notice. Let's see. Options. Oh, yeah. I have the editor font. Oh, and the terminal. Yeah, that's the font type. Huh. I must have a. So maybe some of your versions actually has an option to control the shell versus the editor. I didn't see one, but so we'll have to flip-flop between either. I probably will just turn this option off right now and force it to split the columns across, just because that looks a little cleaner versus me reducing the font size over and over. I will keep this one on, or actually let's turn this one off for now too, because I don't actually need to see all this other stuff. It's still there, just it's just not displaying it. It's making it fit in the 40 columns or whatever I have. And that's actually even cleaner because I don't need to see what's in there for our code to work. All right, and we don't actually need to print this. That's just kind of a good thing periodically to do, is if you expect to have a certain amount of information, data, stuff that you process, print it, and then see if it's actually printing what you expected, and then you can comment that out later so that you don't actually, because you don't need to print it. It's just a troubleshooting thing. All right, so depending on, actually yours should all look the same because we just did the head, which is the first 5 rows. There's similar ones like tail, and you can specify head and do the 7 rows instead of 5 rows. So you can specify exactly how many, and you can do the tail to do the little bottom 5 rows or bottom 7 or however many you want to do. So you can do different things to output specific parts of the data. But what we want to do is we want to figure out, we have input, for me, I chose 1983. That may or may not be an election year. So we want the election year that's closest to 1983. So that's what this little piece of code is going to do. It's going to take the election year equaling your birth year minus your birth year mod 4. So it'll take the divide it by 4 and subtract that off. So let's see. Where's my, there. Let's go down here. Election year. Oh, and this is a common naming style where you have, if you have variables that are 2 words, the first word is lowercase, and then you start the second word with a capital letter. That just makes it a little more readable. It has nothing to do with it only works that way. It's just a style for variables a lot of times. If you have variables that are made up of 2 words, makes it more readable. It doesn't actually, you could have it all lowercase, you could have it all uppercase if you wanted to. So birth year mod 4. All right. Mod 4. All right. And then we could print that out. Print election year. Actually, let's print both. Let's print our birth year and print our election year. Oh, I put a capital P. It didn't like that. Lowercase p. All right, let's run this. I did comment out everything else, so that should be. So we said 83 was our birth year. Now it actually should have picked 84, but it doesn't know. Yeah, we didn't make it sophisticated enough to find the one that's closest. It just found the one that was previous to the way we did it. So we could be a little more sophisticated with our calculation here to actually get 1984 being the closer election year. But it found an election year prior to our birth year, so that's okay. Good enough for what we're doing. So now we have some search terms. We have the election year you're looking for, in this case 1980, and we have the state we're looking for. We just hard-coded that in. So 1980 in Louisiana, we wanted to find out who won. Yep. It's mod 4. It's a mathematical operation that takes divides it by 4 and and takes the remainder. Mod 4. Well, 4 is not key to it. Modulus would be the actual thing. Modular homes. Modular elasticity. Well, good grief. I just want to see the Python. I guess if I put Python in there, it would, yeah, the percent symbol is the modulus operator. So it gives you the remainder when you divide by, in this case, 4. And we're dividing by 4 because we want to know, we know that the election years are every 4 years. And so you could have calculated this multiple ways, I assume. right. This little line is just printing it out. We have to actually write print election year for that to happen. All right, so now what we're doing with these two, line 10 and line 11, we are establishing the conditions, basically the search terms for what we're going to go and try to cross-reference in this database. So the database has columns on it. You know, it has, well, most of them have nothing in the notes, but I guess some of them might. But it has version, total votes, candidate votes, write-in votes, all this, or was write-in allowed, the candidate name, what office they were running for, all this kind of stuff. And year and state are the things that we're interested in. So we're going to search through the state column for our birth state. We're going to search through the year column for the year, the election year that was on or before whatever birth year we put in. So our conditions are going to be condition 1, that doesn't matter what it's called, but condition 1 is we're going to look through our data frame. Our data frame is the thing that holds all of the data. We're going to look in the column named year. That's why we left the headings on here, is because we needed them to be named. So we're going to look through the column named year and find whatever we have coded in as the election year. Election year for me was 1980, so it's going to find the years that are 1980. So we can take this guy, put him over here. I'll need another space. And then we'll have another one that does the same exact thing, but it's going to be condition 2, and it's going to find the state that we have hard-coded in. And I have hard-coded Louisiana in. So this election year for me is 1980. Well, actually, the birth year is 1983 is what I put, but it calculated the election year is 1980. And then we'll have, for me, this one is Louisiana. So if you have different numbers in here, you'll get different output. If you did a different state, if you did a different year, then you'll get potentially different outputs, because I assume the same candidates wouldn't be running every year. All right. So now we have these two conditions. We need to tell it to go find these conditions. So the results is just a variable where we want to store our results. And we're going to go to our data frame and together both these conditions. So where both of these conditions are true, where the year column has numbers that match 1980, and where the state column has numbers that match Louisiana, those will get put into this variable called results. And then it doesn't do anything, so we actually want to see the results. We need to print results, and that'll print out anything that matches. So let's see, let's not show these. I mean, you could, but we don't need to. So I just commented out the printing the birth year and the election year. That's fine. And then we're going to print whatever gets put into this results. Let's see. So it's searching. All right, it found this stuff, and it found 1980. Now I kind of need to see these because that's what I'm interested in, is who's the candidate this year, but I can't see it. So let's go back to our code. We could just expand the columns and see who's in there, and see what office they were running for and how many votes they got. But this little line is going to create a file, or well, not a file, a variable called data that will sort them. And then here I'm going to go in, and this is where I'm probably just going to copy these blocks of code. But these are similar to the ones where we went and found the team name. You know, Clemson was index 0. This is the same type of thing where we're finding particular locations in this data file that we created right here. So this one basically goes and grabs the list that we generated in results, sorts it by candidate votes, and figures out who got the most votes. And it only takes the top 2 rows. So let's do that. Actually, let's not print. Well, we'll comment that out. So I'm going to hide this one. So we're not printing our results anymore because those aren't the final results. This one sorts the by the candidate votes. Again, that's a column that's not shown on here, but it's one of these columns was the number of votes they actually got, and it was named candidate votes. And we are going to take the top two, so the column headings and the one with the most candidate votes. And well, here actually, no, it's going to take the top two rows, not the column headings. So it'll take the leading candidate and the next leading one. So this example is from, I didn't notice when this was from, 88. And so it takes George Bush, H. Bush, and Michael Dukakis, and it gets, based on their candidate votes, it figures out that they got the most votes, with George Bush getting a few more than Michael Dukakis. So for us, if we print it, well, we print this, let's see what we get. So let's print data. Oh, I think I did. Yeah, I think I didn't copy it. There we go. All right, now let's see what we get. And ours actually is not going to show up unless we make it show all the columns. All right. All right, so I get Ronald Reagan and Jimmy Carter, and Ronald Reagan edged out Jimmy Carter in Louisiana. So in a different state, that might have been flip-flop. Florida might have been different. In fact, let's see. Nope, Ronald Reagan also won Florida. New York. I don't think. I think maybe Georgia. Where's Jimmy Carter from? Is he from Georgia? Somewhere like that. Yeah, he won Georgia. There we go. All right, so it works. All right, but that's not what we wanted to do. That is part of what we wanted to do. All right, so what this does is now it goes in and it finds particular pieces of data. So we've got the winner's name, the winner's party, were they Democrat, Republican, Independent, whatever, the number of votes that the winner got, and the number of votes the runner-up got. So basically, we're going through our results, or actually our data based on the results. So the results gave us the combination of state and year. The data gave us the top two candidate vote getters in that results file. And now we're going into the data file or data variable list and finding particular pieces of information. So that's what this is doing. And this is kind of based on the idea that we sorted this data so that the most votes were at the top, next most were at the second position, third most, and so forth. And so the 0, 0, and the 1 here are going to those particular positions in the data file. So, oh, wait, I didn't want that there. Not there. Put that after we've done those. We're going to erase that data one. Print that. All right. So now we've got the candidate. We've assigned a winner's name, a winner's party, a winner vote, and a runner-up vote. And now we can format some output. And that's what this line does, or these 4 lines do. There are a bunch of print statements. This is a little bit different than the formatting we did last time. So let's copy this and look at what it's doing. So it's the same idea where we're printing stuff and we're going to input some variable value. Last time we used the curly braces and the dot format at the end of the print command. Here, they've got everything inside the print command. So print and then some stuff in quotes, and then they're adding or concatenating, in this case, just a variable. It's not in quotes, so it's just going to print the value of that variable. They're specifically saying that that is a string, so the year is a string. Some of these over here This one looks weird. It's actually using a string, but it's doing math on it. So it does figure out that I'm going to print it as a string, but I have to do math on these. So Python, not typecasting things, can figure this out, that it can actually do math on these two because they're numbers, and then display them as strings, so that they can be inside this print command. Basically all that's doing. So this is, doesn't look too readable, but you could probably figure out what it's going to say in the whatever year, U.S. presidential election, the presidential candidate, and then whoever won by, or of the Democrat-Republican Party, won by, and then the math to calculate how many votes the winner had over the runner-up, votes with however many votes they actually got in that state. So mine will say something about Ronald Reagan. All right, 80, Reagan, Ronald. Well, so it doesn't actually rearrange their names to be first and last name, but they're Republican. They won by 84,000 votes. There's their number of votes in Louisiana. And so now this little thing could go in. If we changed birth date, birth year, birth state, it would go and do that same thing for any year and state in our data set. So from 1976 to 20, when did it go to? 2016, I think, was when it ended for this set of data. I guess we haven't had another election since then, so that's why it ends there. Another presidential election. So this process would work, I think, probably the best for number 3, where you've got the salary data. It's just spread across multiple Excel sheets. I think what I would do is I would download all of the Excel files and paste them into a single file, each on their own sheet. And that way you could reference the sheet for 2005 and put that into a data frame. And then you could reference another one for a different year and so forth. And that probably is the best way to do it. There might be another way that's even cleaner. Yeah. Right. For each sheet. Different sheet name. So this would be like 2005 and some variable here. And then I guess you could use DF. I guess it'll let you do, well, it's not going to work if I do a DF1 here, because all my other stuff references DF. I think you can just go in and make a second one, that reads a different sheet. And then you could do your operations on that. So I think that's probably there's probably a little bit better way to go and create one data frame that has everything in it. Read from this sheet to get these chemical, biomed, whatever, and then append to the same file and create one giant thing that has just the stuff you want. That's probably a little bit cleaner. It would take a little bit different approach. You would read them in like this, and each read their individual sheets, and then take that and kind of how they did here with do the results, but instead of just putting it into one file or put in one set of results into that file, keep appending to that results or whatever you want to call it, so that you keep adding the years to that one list. That would probably be the best route. I'm not 100% sure that's the best route. It's certainly not the only route. But I think this one is the most like what you're going to do for that homework 3, since it's pulling it's pulling select pieces of data from a lot of other data that you don't actually need. So I think this one is going to be most useful. The others, you were using every piece of data. You were just plotting all the temperatures or whatever, so you weren't having to select little pieces of data. And there's the whole script down here if you just wanted to copy the whole thing. But this is available. You can go to Excel data in Python, and that'll stay out there for you to look at and see if you want to go back and reference it. Let's see. I've actually posted these on class 3, but we didn't look at them. I don't want to read through these numbering system things. I think I'll maybe look at them, but these are useful for understanding a little bit more about hex and binary and how these things work. This one's starting out with base 10, but I'm not going to read this to you. So I would go, if I were you, and read these. They're not terribly long, like 3 pages. So they're not long, but I don't want to sit here and read them to you because that'd be a little ridiculous. So numbering systems, this is some code. Actually, we might look at the code because that might be useful to look at. Let's look at that. Yeah. So, right, I think that's going to be the best way. I don't want the data files, so the Excel or the CSVs or the tab. I don't want those. I want the Python code and the output. So it has a chart, a graph, these plots or whatever. So that, and I would cut and paste into Word, and then there should be a spot to upload it. Yeah, and just upload it right here. The best thing is to upload it as a PDF. Just print a PDF from Word. But it'll take other files, like it'll take a Word file and everything. The way this stuff grades, though, no, I don't need a paper copy. I want a digital one. I think the other class might be doing paper because they've got to turn in all their work, but digital is fine for me. So I would just upload it here as a PDF, and it will be probably a lot of pages, but I don't need the data, so I don't need the Excel files and things like that, the raw data. I don't need that. Everybody actually should have the same set of raw data anyway, so I don't need that. Let's look at this. I opened it somewhere. Where did I put it? All right, here it is. So this is a lot. Let's copy, put that into here. Let's add a new one. All right. A lot of it is comments, but it's explaining what it's doing. So this goes along with the little 3-page document on numbering systems, and basically it's a hard-coded way to convert, in this case, binary to decimal for that one, hexadecimal to decimal, base 3 to decimal. So these lines here are manually converting, in this case, binary 1001101 into a decimal number. So there's nothing in here that like you're ever going to actually do. This is not how you would go and convert binary to decimal. You would just do it. There's a command for that. But this one like breaks it out step by step so that you could see the math and how it happens. In base 16, the hexadecimal stuff, it's doing the same thing here. So what I would do is I would read this thing, number 8, numbering systems. What is in this one? This is more how you would actually do the conversions here using the built-in commands. This one is like spelling it out mathematically. This character encodings one is how do you get letters and the different symbols encoded in binary. So it talks through that. Serial write and serial peripheral interface, those are things that we're going to use soon. We don't need to look at those yet. In fact, I might move those because they're not. Let's move them to next class. Move it there. Because those we don't need to get to just yet. So I think obviously homework 1 is the primary concern. Once you get that done, look over that numbering system stuff. It's the kind of stuff that you'll probably have some multiple choice questions on the exam, converting decimal to binary and vice versa, and that kind of stuff, or something, a question about a base 16 system or a base made up number system. So look over those documents after you get homework 1 done. We will do soldering. I will do soldering in class on Thursday. You can do your soldering. If you want to do it now, you can actually do your soldering now. The room is open. I haven't looked to see if it's ready or not, but it does have soldering irons in it. You probably will need your own solder because I don't know that solder is going to stay sitting out on the tables in there without it getting used up or whatever. So I didn't check. I would assume you need your own solder. If you do want to go ahead and solder, then this on today's class. If you don't know what to do, then this little PowerPoint will give you the basics of what you're going to do. We're going to start with some thermistor, like really simple data collection, but you do need your SD card, which starts right here. So you got to solder all these little headers onto the card. Now your SD card doesn't look exactly like this, but the headers are all the same. Your card itself, I think, has a little bit different stuff in the middle here, but that's okay. The biggest thing on here is, I think even on your board, you can solder to the inside or the outside. So solder to the ones that match up where it snaps onto the Arduino. And if you do this, on your own, make sure that the little pins stick more or less perpendicular to the board. If you have them splayed in or out, then it's going to be tough to plug it into the Arduino. This thing's going to be a shield that plugs on top of your Arduino. If those pins don't line up with the pins on with the sockets on the Arduino, then you're going to have to break it loose or something, or bend stuff to make it fit on there. So that's going to be our first big soldering job. We'll also solder up a photoresistor too, but that shouldn't be a big deal. You've actually done that before. But I'll do some of this in class on Thursday, so it's not a rush to do it right now. But if you have the stuff ready and you want to, you can go ahead and solder. So I think we're good for today. We've got plenty of time. If you have questions you need to ask or work or whatever, you should be good.